This conference will now be recorded.
Let's wait for another 2 minutes for others to join. Hey guys, can you guys hear me?
Venkat, I can see your screen. I can't.
Okay, you can't see my screen. Okay, sure. One second. So, just want to know, like, Amul and Deepak, have you guys worked on the supply planning side of the APO?
Yes, Venkat, I have worked.
Okay. And Deepak, you?
Uh, Not much, but yes, I have that. area.
Okay. And Amul, like, what parts of the supply planning you have worked on?
I worked on heuristic, optimizer, CTM deployment.
Okay, great.
Yeah,
Okay,
yeah.
cool.
All planning tools, basically. Yeah.
Superb. Nice. So, yeah, so we'll start with the supply planning from today and next uh, 5 days or something, we'll dwell on the supply planning side. So we just done with the demand planning side. So there's one more topic left, that is promotion planning. Um, that I'll cover in time. Once the supply planning is done, I'll cover on that. So, but the demand planning, so in the demand planning, we have seen the statistical forecasting, how we create a profile from front-end Fiori interface, how we assign multiple algorithms into it, how we specify the input key figures, output key figures, how we cleanse our data, and how we also maintain the forecast error measures, all that stuff in the profile, and run the forecasting profile from front end, again, Fiori interface, application jobs, or Excel interface, and get the forecasting output. Next topic is ABC XY segmentation. You've seen that, how to segment your entire planning objects and specify them different classes as per your thresholds, so that you will know which class is contributing more to your organization's revenue, or which one you should prioritize in terms of planning. Third topic we have seen is the product life cycles, phasing in, phasing out, and and if you specify that a product is phasing out, how the forecasting run will respect it, and it will give the forecasting accordingly. When it is a new product, you can say that there is an old product which is a similar product to the new product, so that the old product's history can be considered for the new product's forecasting process. So all that again will create some kind of assignments in the product lifecycle app, and then we run the forecasting. We can see the results. We have seen the data realignment where the planning objects has to be changed when a DC is getting closed, a new DC is coming in, or when a brand is getting changed, or when a product family is getting split. You want your planning data to get changed. It could be your master data getting changed, or it could be your key figures getting changed. So you need to create a realignment project and specify the rules accordingly. Hey, I'm sorry, guys. Yeah, create a realignment project and then set it to different statuses so that once it is in approved status, we can run the realignment project and can see the impact of the realignment on our entire planning data, both key figure data and then the master data. So these are the things that we do. And then there is also promotion planning. So after the demand planning is done, we'll get an output. Uh, it's called a in IBP, like we call them as a consensus demand. Consensus means like an agreed upon demand. So so that's the main output of the demand planning activity. That what was the demand for a product at a product level and at a customer level, or it could be also at a location level. Locations, I mean DCs or warehouses or anything. So it depends upon the way demand planning process is getting done. When the sales orders are directly coming to a location, and you don't want to have a customer dimension. So yeah, so this could be one simple a supply chain network. So we'll talk about this product S11. This a smartphone uh, that is getting supplied on this supply chain. So on to the right hand side, we can see the customers: Amazon, eBay, and Best Buy. So they'll get shipped from two warehouses. This is warehouse 1, and this is warehouse 2. Warehouse 2 is shipping to eBay and Best Buy. Warehouse 1 is shipping to Amazon and eBay. Again, warehouse 1 is getting sourced from 3 DCs: DC1, DC2, and DC3. Again, DCs are getting sourced from plants. There is a mode of transport also. The sourcing, this could be done by a rail, road, truck, air, cargo, like whatever. And then there's ultimately there is one supplier called Intel, and he is giving a chips chips that are getting used in the manufacturing process of S11 will be sent by Intel to the production facilities, so that the production of the finished good will happen and it would be shipped to the DCs, and from DCs it would go to a warehouse, and from warehouse it goes to the customers. So the demand planning will say that for a product called S11 at a week called like let's say there's week 30 of 2019, there is a demand of 1000, and eBay will have some demand of 500, and Best Buy is having a demand of 100. So now the total demand for S11 is 1600. So the supply planning is responsible to come up with the plan that would meet the demand of 1600 on the week of week 30 to all these customers for this product S11. The supply planning will say, like once it will take this input, the time series input, the key figure data input, that is 1500, takes that input. Once the supply planning engine is run, it could be a heuristic or it could be an optimizer. It runs and it will tell that how much has to be first produced in the production facilities. 1600 is a demand. So how much plant 1 has to produce, how much plant 2 has to produce. So once it is done, uh, so how that inventory will be moved from plant to DCs, and from DCs to warehouse, and from warehouses to the customers. And if the plant 1 has to make a particular number of finished goods, how much of a components that it requires, and how it's going to procure that raw components from its vendors that are connected to this particular plant. So, and there are also other outputs that what the supply planning gives, but like these are the like major outputs that your production plan, your transportation plan, and then your procurement plan. And then yeah, there are some inventory projected stocks, like how much of the stocks has to be maintained at all the DCs and plants and warehouses. So and again inputs. So like as we are like just talking about, like any algorithm needs an inputs and then there would be some outputs and there are some variables. The variables will impact how the outputs will come in. So just like that, for the heuristic and for the optimizer, there are some inputs like demands, safety stock targets, available capacities, and etc. Supply planning will give you the outputs that we talked: production plan, transportation plan, procurement plan, projected stocks, and there are and other stuff like etc. So and then then there are some variables that would impact this entire supply planning run. So from an IBP perspective, so today we'll completely spend our time on setting up the master data, and from tomorrow onwards we'll take different scenarios, and then we'll go with the heuristics. And then again in heuristics there is another thing called a supply propagation heuristic, and then after that we'll go with the optimizer. And like whatever we deal with in different scenarios, so that we can understand this supply planning once more effectively. So today we'll talk about the master data. So mm, just like in APO, here also in IVP, there are just only two entities, that is a customer and then the locations. This is called location, this is called customer. All the warehouses, DCs, plants, vendors, everything would be called as a location only. Customers will be called as a customer. So now we'll talk about different master data. The first master data is obviously the product master data. Simple master data. Let's talk about simple master data. Product, location, customer, and then this part, a transportation lane. This is called location source. So there are three types of sources that we have in here. So first is a product master data, and then next is a customer master data, and then there is a location master data. So then the component master data come in, that is we'll say location product. So this is the logical combinations of all the products and locations. So like we have talked about it, right? So for example, there is another product called S12, uh, but S12 will never get let's say this is warehouse 2. So S12 will not go through warehouse 2 because warehouse 2 is in a different region. So S12 will always be sold only to Amazon and eBay, and then S12 will be sent only from the warehouse 1. So in that case, the S12 will not be extended to the warehouse 2. So you're getting, so that's the thing. And again, same with the case of customer product. So we'll specify that what products will be sold to the what customers. So that is maintained in the master data called as a customer product. So that is the fourth and fifth master data that we have to maintain. Next, we have to maintain the sources of supply. So the name itself is signifying that we are actually specifying the sources for a particular, for the suppliers. The first thing is called the location source. That means how a location will get its sourcing supply. So for example, in here, the warehouse, if there is a demand of 200 for S11, so how this 200 this warehouse will get? So what sourcing options it have? It has two options. So it is DC1 and DC2. So that is maintained in a master data called as a location source of supply. Next, we have the customer source of supply. So just like that, just like location source of supply, this is customer source of supply. How a particular customer will be sourced, what all locations that it is been assigned to, that it is been tagged to. So it's a transportation lane, obviously, from from a APO or a PPDS perspective. If you see, this is a transportation lane which says that what is your sourcing location, what is your destination location, or shipping location, destination location, and what is a product that is getting moved into this. So that's a transportation lane we have to maintain. The next is production source of supply. That means so warehouse is getting sourced from DC is getting sourced from plant, and from where plant is getting sourced from. So it could source from a co-packer or a co-manufacturer, or it could source it from within itself by doing a production activity. So that's why it's called as a production source of supply. So production source of supply will have two master datas. So I mean, it's actually it's just called the production source of supply, but the actual name is production source header. This is BOM details, bill of material details, but this is more at a header level. Then we have something else that is called as a production source item. Item deals about the item level details. Okay, next is resource. All your storage resources, handling resources, all your production resources, and all that stuff, it's called as a resource master data. And we have to assign resources to a particular location, that is called as a location resource. And then we have so location resource product is a master data which talks about storage resources and handling resources. Production source resource is a master data that talks about the production activity. Okay, and then finally conversion is there, which is obviously is also an important one. But yeah, so these are the master data that we have to maintain to let our supply planning run. Okay, so now we'll get into the system and then we'll configure our supply chain. Getting inside our test config to planning area. So I'm clicking on master data workbook. I'll pick up the product master data, edit mode. We'll pick up the location, customers anyway I think we have. Next I'll pick up location product, customer product. And yeah, I mean in real world all these master data will be coming from S4 system, so it won't be any manual maintenance. So but just for our discussion sake, I'm loading everything from the master data workbook, or you can also create a flat file, a CSV file, and then load it into the system. So I maintain location product, customer product. Now I'll maintain sources of supply. First thing is location source. Next is customer source. So we'll maintain this for now, and then we'll get into the resources side. I'm opening the product master data. So yeah, it is, we've opened in edit mode. So that's why the key attribute comes in the orange color, and also you'll see a button called save changes here. If you open it in normal mode, the save changes will not be visible here. And also if you open an edit mode and if you wait for like after third minute, I think this would automatically get turned off. I mean the edit connection will get turned off, and then you won't see any save changes. That means you have to reopen your master data workbook again in edit mode and save it. Okay, so there are a lot of products already getting maintained. Now let's maintain S12, and then so what all components we need to make the S12. So we'll say a chip, and we'll say a battery. Yeah, so for now we'll just keep only 3 products: S12, chip, and a battery. So and we have other like other stuff like ABC description code. You remember all this stuff, ABC IDs that will get generated by running ABC algorithm. We have a brand, category. This is all comes to the product hierarchy, how all helpful for all the reporting stuff and all. So item type, category indicated, material type ID, and all that stuff. For supply planning run, we'll talk about the mandatory stuff which are required for the supply planning run to happen. So I'm going to the base unit of measure here. This is what we need. Okay, I maintain the products. I'm going to the location master data. So again, there are a lot of other locations, but let's create like new locations for our discussion's sake. I'm following a naming convention S11. I'll say this is a warehouse 1, it's a DC1, DC2, or we don't even need a warehouse 1. So let's keep things simple. Um, I just created only 4 locations. I created only 2 DCs, which will be connected to a customer, and then the DCs will be again further connected back to one production location, that is plant 101. And then I have a vendor Intel, which gives my chip to the plant 101. So anything else I'm just thinking how the supply chain algorithm would run with this network. Yeah, I think we'll keep things simple because it will if it will get complicated, it unnecessary things. So I'm coming to the column J, which is called location type. So if the location type, if you maintain it as a V, that means system understands that this is a vendor location. And if it is not V, that means it is part of your supply chain. Even Intel is part of your supply chain, but it stays outside of your supply chain. If you don't specify it as a V, that means you are taking some kind of a ownership of that location, and yeah, so it's part of your supply chain kind of a thing. So I specified that Intel is the vendor. I'm going to the customer master data. I think we have all these customers anyway. Let's pick up only Amazon, and then we'll build from there. So I'm going to the location product here. So now I'll pick up all these locations. Now you see, this is where I do the mapping of locations and products. So plant 101 needs all locations, all products. Obviously, it creates S12 by taking chip and a battery. So I have to extend locations and products here. DC1 should be just needing S12. It won't require chip and battery. DC2 also requires just the finished good so that it will do its logistics activity. And Intel just needs the battery. No, not battery, chip. So this is where we do the extension of products to particular locations. Okay, and then there is another important thing that is called as subnetwork ID. So let me first save. So there is something called as a subnetwork ID. That means like we have to create a subnetwork. Subnetwork is part of your entire supply chain network, but it is just a subset of this thing. And subnetwork is a mandatory input for the supply planning runs to happen. So for now, I'm coming to the subnetwork. I'm creating a subnetwork called S11. So now I'm coming to location product, and I'm saying that this all becomes S11. So I created a separate network for just S11 product, so that a particular planner is responsible for the entire supply planning process of this S11 product. Or it could be North America is one subnetwork, or South India could be one subnetwork, and all the DCs and stuff belonging to the South India. So when you run your optimizer or heuristic, so you will say that please run on South India subnetwork, and system will consider only the demands inside that South India subnetwork, and it will do the production and deployment and everything inside that South India subnetwork. So that is what it is. So specifying subnetwork
So
here.
Venkat, I
Sure.
didn't
Yes.
get that quite. Is it similar to the production planner or the supply planner ID that we have in FAO?
Yeah, but I think that planner is not a mandatory input, I think, right? So, but here it is, when you run supply planning, it will ask for the sub network, like for not for what network I have to run the supply planning run.
Okay, so subnetwork ID is attribute of location, right? Or
Location
okay,
product,
location
location.
product.
Yes,
Okay, so if we select this subnetwork ID, so everything belonging to this subnetwork ID will be run, right?
exactly.
In
Yes,
okay, okay.
sure.
But is it
And also,
mandatory? And
yes, it's a mandatory thing. So if you don't have sub network, it will not, uh, the algorithm itself will not even run. I mean, that's the main input that has to be selected, and then it has to be deployed. It has to be, processed.
okay, yeah.
And the same DC one can be mapped to a sub other product, and then you can call that as different subnetwork. So, but a unique combination of location and product should be belonging to only one subnetwork. Okay, so it depends upon like how you're slicing your entire network, and then accordingly you have to maintain your this thing. Now customer product. Just take Amazon, and then we'll put some demands at the Amazon, and then we'll run our supply chain. Now location source. So you see here, what is your ship from location, column C, that is your shipping location. What is your location ID? This is your destination location. And what is a product, and other transportation and related details. So there has to be a mode of transport also. I think that I haven't extended to this master data. So there would be something called as a mode of transport ID also. So we can actually maintain at that detail, and also maintain the lead times for every mode of transport, and etc, etc. So for now, plant 101 is shipping to DC1, DC2. Is it making sense? 101 is shipped from location, sending to DC1. What it is shipping? S12. No, not S12. I think it is S11, right? Okay. I don't know why I gave the subnetwork as S11. Yeah, okay, whatever. This thing, and then I bought the plant 101. It is getting Intel. So we can also maintain lead times. For now, I'm not maintaining anything. So just saving it. Customer source. Just have Amazon, but it has two options: DC1, DC2. See, Amazon will get from either a DC1 or a DC2. Or the third sourcing thing, that is called production source header. So here we'll maintain what is a location, production location, what is a product that is getting produced, and then what is a source ID. Source ID is a BOM name. So I'll come here and I'll say, so there is only one production facility, plant 101. It is producing S12. So I'll say S12 production version PV001. And then the other important thing is this output coefficient. That means the coefficient of the output product. Output product is S12. So how many it will produce if I process this particular source ID, that is this bomb. It will just produce only one. And then the other important thing is the source type. So now it has a three source type. One is a P, that means it is internally producing. If it is C, that means it's a co-product. And if it is U, that means it is bringing from an external party. Okay, so for now I kept it as a P.
Hey, where do you see that data? I mean, that field values in that,
Uh, I
that
mean, yeah,
production
I mean,
type.
it's not like in the typical SAP screen. It's not like, you double click and you'll see all possible values. So we have to remember and we have to maintain them accordingly.
Okay, in Fiori.
No, not even in Fury. But yeah, I think in help we have, obviously. So there will be some documentation available. So I'll be sharing that to you guys so that you can refer that and maintain it accordingly.
Okay, and one more thing, in location ID column, I'm
Hmm.
seeing this S11 plant 101. That is
Yeah,
location product, right? Not the location. Am I right? I mean, if I can you go to location tab one more time just to confirm?
sure.
Yeah. So if you see, okay, S11 plant. Okay, okay, got it, got it. It's a location, not
Yes.
production. Okay. Yeah. Thanks.
So now I'm maintaining the item level details. That is what all components are required to produce, to actually process this source ID. So this S12 production version 001. So it requires two materials. So it requires a chip and a battery. So let's say that it needs two chips and it requires one battery. So that is what we maintain in the component coefficient. Okay, so we're done with this, and we have to maintain now the resources. So let me open up the resource master data and then the location resource and the conversion factor. There are already a lot of resources here. Plant 101 RES resource 101. So this is a resource name I have maintained. Coming to the location resource. So I'll pick up this plant 101 location. For now, I'm just maintaining only production resource. That is a mandatory thing. If you're running your optimizer, that is where we specify all our capacities, what is available capacity, and etc. Storage resources and others are like complementary, not complementary. I mean, they are not, mandatory things, but you can very well maintain them and let your supply plan, getting influenced by those other resources. So this is location ID, and then resources this. So now the important thing is a capacity supply. So here you can maintain the capacity supply. So that is 168 hours. Then this is a capacity that will be supplied on this resource inside this location plant 101. Now, if the capacities are changing, then you can maintain the column H, and then you can maintain something called as X. That means system has to read the data not from the master data element, but from the key figure. What's the difference between reading from key figure and reading from master data element? There is a lot of difference. The difference is that if it is reading from master data, it is a static value. 168 is 168 across the horizon. But if it is a key figure, then you can very well maintain different values for different week. Okay, so that's why we'll maintain time series indicator. That means the name itself is signifying, right, that it is an indicator that specifies that this is a time series. Okay, it has to maintain a key figure. Again, what key figure I have to maintain? So there's a key figure with the same name that's called capacity supply. So you have to go there and maintain. You can maintain multiple data points. Like you can maintain 168 hours in 2 weeks, and last week you can say that there's a downtime happening. That's why it is just 100 or something like that. And if it is a key figure, the other advantage is that you can actually do some calculations to populate that value. Remember, we started with a capacity planning exercise itself. The whole output of that entire capacity maintenance activities. Sorry. So the output of that entire maintenance activity is the available capacity, and I can do a lot of maths on it. I'll do maintenance jobs, this and that. I'll do some adjustments, and then I'll finally come up with a value that I'll use it to populate a key figure called capacity supply, which your supply planning engine will respect. So that's another use of making this as a time series indicator. And then you have other capacity expansions, and you can say that I can do another 15 hours on this resource inside this location by doing an overtime. I mean, I put up an extra labor and then I'll do it. Again, time series indicator. You say that I want a time series indicator. So time series indicators are everywhere. That's a thing in IBP. So even the output coefficients also, you see, this is one, and the other is output coefficient time series indicator. If you say X here, that means it becomes time series indicator. I have an example for this. We'll see this as one of the scenario and how we can use this to actually meet your supply planning requirements. For example, if you say the output coefficient is 0, that means this, you're saying that if you process this bomb, you will get 0 units of S12. That means in a way that you are not supposed to produce anything. I mean, there's no point of producing. So how we can use this output coefficient time series indicator is that sometimes some production versions becomes invalid, or we don't want to choose a particular production version. So in that case, we can make this as a time series indicator, and then we can let the planner to maintain either a 1 or a 0. So if you maintain 0, that means the production will not happen. That means it is actually becoming some kind of a invalid production version, right? So for the same S12, you can maintain multiple production versions. And then with the ones and zeros, you can actually influence whether the your supply plan should pick it up or not. Okay, you can call it as a run strategy kind of a thing. That in this particular quarter, I'll not go to the production version 3, but I'll fix to production version 2. Okay, why? Maybe production version 2 is getting produced on a robotic assembler, and then I want to do my entire production on the robotic assembler, and the robotic assembler will be functioning on production version 2. So that's why I'll maintain 1 for production version 2. In others, I maintain 0. If I maintain 0, supply planning will not pick it up. So that's the thing with the time series indicator. You make it as a time series, and then you can play as per the time. Hope you guys are following. So yeah, that's the thing with expansions. You maintain an expansion, 10 hours or 15 hours, and that is extra capacity that it will have inside this resource on that particular location. And then there's a time series indicator, and there's also a cost rate that you will incur if you do an expansion. Obviously, right, you're doing an overtime, and definitely you'll incur some cost. You can also maintain the costs in a different key figure, and you guys must be knowing the optimizer is all about cost. There are costs for everything, so too many costs, so many costs in optimizer. Every bit of your supply chain can be influenced with a cost rate. Yeah, so you give a capacity supply expansion kind of a high cost, then optimizer will not easily pick up this particular resource and give us a overtime production supply plan. Okay. But if the non-deliveries are so high, okay, what is non-delivery? Non-delivery cost rate is, I think you guys must be knowing that the cost that you incur if you don't deliver it to the product or to a location also. So if that means the if you say high cost, that you are incurring a lot of costs if you don't ship, if you don't meet, if you don't supply this product. So in that cases, then optimizer would generously do an overtime and incur a lot of production costs, but still would produce it and ship it and meet the demand. So that's the thing with the supply expansions. The other thing is the constraint type. If you don't specify anything, then system thinks that this is an infinite resource. But for now, I maintain it as F, but it doesn't matter with the heuristics because heuristics don't care about the capacities. I think I'm going overboard, guys, but yeah, we'll follow everything in a step-by-step thing. So next uh, 2-3 days we'll spend on heuristic itself. So yeah, so heuristics won't care about the capacity of this resource. Heuristics thinks that it's an infinite resource. It will always meet your demand. You say 100 is your demand, it will meet that 100 demand. You say 1 million is my demand, it will meet that 1 million demand. You say 100 million is my demand, it will meet 100 million demand. It doesn't care about whether you have the capacity to do it, you have this thing to do it. So how it will do it? So that remaining thing, it would result in a different key figure called as a projected stock. So in that projected stock, it will actually give a very high negative value. That means production can happen only 168. Let's just say every hour I am producing one. At max I can produce 168 with this resource, with this production source header. The demand is some like 1000, let's say, or let's say 200 is your demand. So now, but still heuristic will say that okay, I'll do the production of 200, I'll ship you 200, I'll meet your demand of 200. But if you actually go into the details, the production happens only for 168, but whereas that remaining 32 actually becomes as a negative projected stock, so that the planners will know that where are my bottlenecks, right? That's the thing about heuristic. So you run your heuristic with an intention of meeting all your demands. But if I meet all my demands, what will actually happen to my capacity utilizations and my projected stocks and etc. Yeah, I think we are going overboard, but that's the thing about the constraint type. Optimizer will respect if you say it is F, that is it's a finite resource. If you don't specify anything, then it becomes infinite resource. Resource type. Don't specify anything, it becomes a production resource by default. If you say it is 1, that means it's a storage resource. If you say it is 2, then it becomes a handling resource. If it is 3, it becomes a transportation resource. Okay. And then every resource you have to maintain what is available capacity. I'm maintained this. And another important thing is production source resource. So this is where we map a resource with a source ID, a resource with a BOM. So this is not a routing file, which we typically see it in BOM, but it was kind of, you know, on a high level, this is what is. So this is where you specify that this resource ID produces this source ID. Okay, if it has other production version, you will also specify that other production version. You guys are getting it right. So this is where you map everything. Now this is a consumption rate. So I'll say here 0.01. So what does this mean? That to produce 1 unit of, or to produce 1 unit of this source ID, it consumes 0.01 capacity of this resource. Okay, so how much of I produce one, I consume 0.02. I produce two, I consume this much of the capacity. And what is the capacity? Capacity is like 168 hours in a week. So it would like I produce 3 units of not 3 units. If I process this source ID thrice, then I incur 0.03, right? So if I consume total 168 hours, what would be the thing? So it would be like 168 divided by 0.01. This is a 1, 16,800. So that means this resource in a week, it can produce a maximum of 16,800. Okay. And let's see the conversion factor. Make a conversion factor for all these three products. One second, guys. I'm resharing my screen. Small glitch. So yeah, that's all. So we are done with our master data setup. We are good to go and run our this heuristics and all. So here under the supply planner catalog in your Fairy interface, so there are something called S&OP operator profiles. So you click on this. So this is where you maintain your profiles, your heuristics profile, your optimizer profile, and everything. So let's test config 2. I hope we have some yeah, we have already some profiles, optimizer, forecast consumption, optimizer, and heuristic. So let's open heuristic. So this is the profile for heuristic. We have general information, how it has to be processed, batch, interactive, and batch. Time profile level, we'll running it at a week level. Primary parameters, what is a heuristic type? Infinite without shortages. And there's also something called supply propagation. You pick up this, then it becomes supply propagation. And there are quotas and how we and heuristic runs always on quotas. I think you guys always know about it. So and there are lots of other things.
Hey,
And
Venkat.
sure.
Yeah, what do you mean by heuristic always runs on quota? I mean, what does that mean?
Oh, okay. So optimizer goes on a cost optimal route. So that
Correct.
means when you say the 1,000 is my demand, so either you can do all your production at this plant 1,000, then you can send it
Mm-hmm.
to this warehouse and it can meet here, or you can do all in here, or you can do 10 here and 990 here. So there could be
Mm-hmm.
like n number of combinations of how you can actually produce 1,000 and ship 1,000. But out of these all combinations, there would be one combination which will incur the least cost. So
Cost, yeah.
optimizer will try to pick it up and will give you the supply plan accordingly. So optimizer say that okay, produce 300 in plant 1, 700 in plant 2. Do your entire shipment to the DC2 because DC2 is having the least transportation cost, least inventory holding cost, and pick this warehouse, etc. But whereas in case of heuristics, so because with the optimizer, the control is kind of a very less because there are costs everywhere. There is inventory cost, there is transportation, there's production cost, there are fixed costs, etc. If the planner wants to have more control on how the demand is getting propagated, demand getting pushed from customer to the warehouses, to the DCs, to the plants, to the vendors, then they'll maintain quotas. quotas is the ratios that if Amazon is having two warehouse, one warehouse two, how much of the demand has to be propagated or has to be split to the warehouse one and warehouse two. So I'll maintain a quota. So if I maintain zero point 0.3 quota, then that 1000 demand would be split as per 0.3 quota to warehouse one, 0.7 to warehouse two.
Yeah, but
So
that is not mandatory, right? I mean, we don't need to maintain the quota. I mean,
if it is a heuristic, we have to maintain. If it is a heuristic, we have to maintain. If it is optimizer, even though you maintain quotas, optimizer doesn't care. So even though you say that my quota is 0.1 and 0.9, that means 0.1 demand, put it on warehouse one, it won't care. It will always look for the cost optimal route and it will do it accordingly. But for heuristics, the quotas are a mandatory thing, and the quotas always has to add up to 1. Okay.
okay,
So
because yeah, because
yeah.
I'm referencing back to APU because in heuristic we didn't need to unless business wants this specifically uh, incorporated into heuristic, then only we would go and maintain the quota. Otherwise,
Okay.
otherwise, what heuristic would do, it would read the uh, transportation duration from the T lanes because we have
Mhm.
multiple sources, right?
Oh yeah.
And
Oh yeah.
wherever it finds the least duration, it will try to get the quantity from, I mean, the shipment from there.
Mhm. Okay.
That was
Sure.
one logic. Then second one is it was like fair share. It's, I mean, the transportation lane time also is the same, that
Mhm.
lead time, then it will do the fair share basically from the
Okay.
road sources. So that's why I asked,
Yeah.
I mean, whether it's always, I mean, in IBP we need to maintain the quota, or I mean, is it like
Yes.
based on
Yes.
the
Yeah. It has to be always maintained. It's a mandatory thing. So
okay.
now let's quickly run the heuristic. Let's not dig deep into it. Tomorrow we'll definitely go scenario by scenario. So for now, um, so I'm maintaining three sources of supplies. You remember customer source, a customer getting source from where locations, or a customer is Amazon getting from warehouse one, warehouse two. Location source, how the DC1, DC2, sorry, DC1, DC2, how they are getting sourced from plant, and plant is getting sourced from Intel. Now production source header, that means the production activity is happening inside plant one and how many production versions are there. So let me maintain just the quotas, and then we'll run our heuristic. So in the customer source, there is something called as this customer sourcing ratio. So Amazon DC1 S12 product. I'm saying 0.3 here and then 0.7 here. This is the ratio. And these ratios also can be time series. So that option is also there. Coming to the location sources. Where is location source? Where is it hiding? We have lot sizes and all that stuff, but yeah, let's focus on location sourcing ratio. Plant 101 is getting from DC1, so there is no way. It's all 1111. Oh, what do I mean by 111? That means if you take from a location perspective here, this DC1, it is having only one sourcing option, that is plant 101. It is not having another plant or any other co-packer or co-manufacturer. Then the ratio has to be 1, right? But whereas in here, if you see the Amazon is having two options, DC1, DC2, then I can actually use a split here. So that's how you have to maintain it. Like you always have to look from the destination perspective, that is your customer perspective, customer product. You see how many combinations are there. Again, here you take a unique combination of location product DC2, how many options it has shipped from. There is only one, then you have to maintain location sourcing ratio as 1. Let's do the same for production source header also here. Where is production sourcing ratio? Production sourcing ratio. Yes, here it is. Let's do the same. Production and source ID, location and product. This location, plant 101, product is S12. How many source IDs I have? I have only one source ID, one production version. Then it has to be 1. If I have another production version too, then I can maintain the ratios as 0.2 and 0.8. That means if there is a demand on this plant of 100, produce 20 units of the demand from production version 1, 80 units of demand from production version 002. So, but for now there is only one unique combination, so just giving one and saving it. Okay, yeah, master data setup is fine. Now let's do the the key figure inputs. I am opening a planning level called a weak product customer. This
Hey,
is
Venkat,
where yes, boss.
just quick question. So which one takes the priority? Because see, I mean, if you're adding a new production version, basically, right?
Hmm.
And that production version would be for the second plant, correct?
Hmm.
Correct. And you're maintaining two different ratios, right? But if you go back to your location source, right? We also have whereas I mean, let's say in another network, not in your case, but let's say in another case where you have two different plants, right? So of course, for that node also from DC to that plant, you'll be maintaining the quota, right? So
Hmm.
that ratio plus your production version ratio, right? So which one takes the priority?
Okay, okay, great, got it. There is this DC,
Mhm.
and then there is this another. Let's say this is CP co-packer. There is a plant.
Mhm.
Uh, Plant is sending to DC. Co-packer is also sending to the plant. So now we're talking about S12 product, and here there is, let's say there is another plant here.
Yeah.
This is two. So there is a demand of 100 here. So you said the ratio is zero point 0.4 here and a 0.6 here. So now if you
Yeah.
run your heuristic, then 100 would be propagated, and here the demand, it's called as a dependent demand. So the plant 1 dependent demand becomes 40. Okay,
Mhm.
and here the dependent demand becomes 60. Let's
Correct. This
forget
is
about
this is as
exactly.
per
So
the quota.
yes,
But what
yes, yes,
about this production version? Like we'll have two
exactly.
different
Yes,
production
yes,
source.
yes, got it. Come on, sorry. So now let's say there is no this thing here. There is no co-packer. That means this plant doesn't have any another location source. Okay, there is only one source available. That is production source. So now the production source, you maintain production sourcing ratio as 1. Okay, that means whatever demand is there, that 40 would be pushed onto the production version, that is source ID, and system does a production of 40 and ships it 40. Okay, you clear
Okay.
this
Yeah.
now? Okay,
Yeah.
next
Yeah.
point. Now it has two options, that it can actually procure it from co-packer. It can also do its internal production. Now how the ratios will happen? Now if you say that my production sourcing ratio, which is available part of the master data called production source header, so there you maintain it as a 0.5, and you also have location sourcing ratio, that is co-packer to plant. So here if you say this as 0.5, now how system will do is that in this location plant the demand is 40. Now that 40 will be sourced, 0.5 of the 40 will be sourced from co-packer, 0.5 of the demand will be sourced from internal production. So production becomes here 20, and co-packer will get dependent demand of 20, and co-packer will ship 20. So this plant will get total of 40.
So this production source ratio, will it be applicable to another resource as well in the same plant?
No, production source is for that location, product, and source ID, that BOM level.
Correct, but there could be multiple resources available in the same plant, right? One product can be manufactured at a different resource as well, right? Possible.
Yes, yes, yes.
So that in that case also we can use this PSR, right? This production source ratio.
Oh yes, 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 yes. So for example, there is robotic assembler, and then there is, so robotic assembler does production version 001, 002, and this does production version 003. Let's just say there's only one. So and this is all for particular product. So now inside the production source header, this is production source master data. So this is location ID, this is a product ID, this is a source ID, and then this is production sourcing ratio. So now how you'll maintain is this is plant 101, priority is S12. So now you have 3 production versions here. So now here you can you will maintain the ratios accordingly. So here if you say this 0.3 and this is 0.5 and this is 0.2. So now on this plant there is a demand of 1000, then 300 will be produced from production version 001 on this robotic assembler, and 500 will be on production version 002, and 300 from production version 003, 200 from here. And if you maintain here 0, then when you run it, heuristic will say fail. It will say with an error saying like the ratios are not summing up to 1. So it will always have to sum up to 1 from location and product perspective. It's just 0.8. So now here you have to say 0.5 and 0.5. So now if the demand is of 1000, then system would do 0.5 demand, 0.5 sourcing of demand, 500 on production version 1, 500 on production version 2. So this is how we can maintain multiple production versions and ratios inside.
Yeah, so this is a mandatory field then.
Yes, it's a very well a mandatory field. Yeah. So I'm first maintaining some demands at here. Customer product is S12. The key figure name is consensus demand. This is a mandatory thing that we have to live with this. So this is what I'm talking from the beginning, that um, for the heuristics and optimizers, the key figure names are like standard. You have to use the same inputs and outputs. So you cannot create some z key figure and say that okay, now I want my result to be in this z key figure. It will not happen. You have to do some calculations to populate actually z key figure, but we have to live with the inputs and outputs, the standard which SAP gives, and have a documentation available with me. I'll give it to you. So in case of optimizer, there are some 100 key figures are there, more than 100 I think, which are like total inputs and outputs and indirect inputs and stuff. So how whatever we want to influence the supply plan, we have to live with those key figures. So now I'm maintaining a demand of 1000 here across. This is my demand, saving it. Okay, now let's maintain some capacity supply also. Remember, location, resource. Where is our S11? This one. Going to the another key figure that's called a capacity supply. That is at location level, resource level key figure. So this is our combination. I'm maintaining it here, and then this is called capacity supply. 168 is our capacities. That's it. The major things, inputs, mandatory inputs are this. We're done. We can run our supply plan. Let me open template. We are having a standard template for supply planning runs, where it would hold all the related data points. So tomorrow I'll bring the template. Yes, boss, please.
One more question. Sorry.
Yeah, please.
So heuristic or any basically planning engine, runs on specific set of data, right? So
Yes,
right
sir.
now, you have created the forecast as well as the
Mhm.
capacity, right? So when you're running a heuristic, it will consider only these two key figures, or I mean, it will also consider which
A
is
lot.
not.
Yeah, and there are a lot of key figures that it actually considers. For now, to actually start somewhere, I'm starting it with with few inputs. So yes, it considers a lot sizes, lead times, and safety stocks, everything. So it has everything.
Okay, so is there any specific standard template that we have to use to run heuristic?
No. We can run on anything. So if you see, I'm just creating a template just here
Okay.
itself. So this is a customer side. Okay, now copy. Now he'll say um, transportation to say no data font, but that's fine. So for now, let's focus on only these three: customer, transportation, and production. You can actually tomorrow we'll go deep on all the stuff. But for today, dependent demand. Okay, we're done. Um, that is fine. We'll run the algorithm. It will bring it up. What I'm first tab, I am in the customer side. There's a customer called Amazon. Product is S12. This is a consensus demand. You remember, this is the demands that we have, just maintained. So I'm going to the run, picking up the S&OP operator. Drop downs here. Take the heuristic. This is a time horizon. Scenario is baseline. Version is base version. You need to specify a subnetwork. Job shouldn't be scheduled. Cannot create background job. Report error. You see, a subnetwork is a mandatory thing. So let me disconnect and connect back because I just edited the master data and then I need to log in back again so that system can kind of do a refresh on the database. Now again, I'm doing a refresh. My Excel planning view gets activated. Run S&OP operator. You see the planning unit, the third box coming in here. So this is a mandatory. As of now, there's only one planning unit. Planning unit, subnetwork, both are same. So when running it here, it is saying that planning unit. So as of now, there is only one subnetwork that is called S11. So from 29th week of 2019 till the last month of last week of 2021, total 131 periods are getting considered to on this particular heuristic run. Clicking on next one. This has been scheduled. Status S&OP operator. It just takes less than a minute. It's in process. I think this is the first run in this planning area. Maybe it might take a minute more, but usually there this is fast. This is really fast. Yeah, it's finished. Doing a refresh. It has met the demand. 1000 is a demand. Customer receipts is output, and it is saying that the demand has been met. So now you want to know from where this customer receipts means, think from that it is receiving. So receipts means receiving. It's kind of a GR kind of a thing, goods receipt kind of a thing. So customer is receiving 100 in a week to 29. So now you want to know which locations has been shipped the 1000. So I'm doing a quick edit view, add an attribute before. I'm bringing the location dimension. I have two DCs, you remember that the Amazon can be shipped from DC1 and DC2. I'm breaking up this. Okay, you see here, consensus demand location it becomes none. Why? We talked about it, that because the consensus demand is being configured at a base planning level, that is week, product, customer. There is no location dimension. If you are viewing a key figure and you're also bringing another planning level, and it would actually show none there. So we have to pick up your planning levels appropriately so that your Excel sheet looks cleaner. Getting what I'm saying? So if you bring capacity related data, then customer it shows none, product it shows none, and resource only it will give a value. Anyway, yeah, keep that aside. So 1000 is a demand, 300 has been shipped by DC1, 700 has been shipped by DC2 because of the ratios that we have maintained. Now I'm coming to the transportation side. So now we'll see what's happening between my DCs and plants. Okay, there are a lot. So let's filter on S12 product only. It is actually showing the okay. Now you see here, dependent demands is 300 is a demand on DC1, 700 is a demand on DC2, 1000 is a demand on plant 101 because there is no other production location. DC1, DC2 are getting this thing to only plant 101. So now here you see plant 101 is shipped from location. It is shipping to DC1 300. Plant 101 is shipping to DC2 700. You guys are understanding, right? So as per the ratios, whatever we maintain, the demand is getting propagated. Now I go to the production. There it shows actually the production happened on production happened for this thing. Now let's filter on this plant 101. Now let's bring up all the products that are there. We have two other products, right? Battery and stuff. Should hard code the filters. Now you guys can understand. Now the filters actually comes in really handy. So the demand on battery is 1000, whereas the demand on chip is 2000. Why? Because the component coefficient we maintained as 2. That means to produce 1 unit of the S12 smartphone 12, it requires 2 chips. So that's why this is coming as 2000 on chip, and whereas the production is happening on only this. Okay, you guys are understanding it, right? So now let's create a scenario. I'll show it to you the impact of the ratios here. This is giving standard ratios. So now I'm creating a different scenario. So now you guys can also think about how we can do what if analysis. Okay, one second. I'm creating another scenario. So I'm going to the top here, scenarios. I'm picking up both the scenarios. So Now I'll go and modify the master data customer source. So here I'll say 0.5 and 0.5. Now here I'm running the heuristic again, but only on this change in ratios, only on this scenario. I hope you guys are following. We talked about scenarios quite some time back. Scenario is a different plan, and I can create different plans, and I can run any of my operators on that particular plan, so that I can see the impact of that inputs in that plan on the total overall output. So now I'm running on the scenario called change in ratios. It's finished. One second, guys. Kept a filter, that's why it is not coming in. So you can see here with the standard ratios, 300 is getting shipped from DC1, but in the changing in the ratios, 500 is coming from DC101, and 500 is coming from DC102, and 700 is coming from DC2 in case of standard ratios. You guys understood the impact of the ratios? So now let me say here, I'll say this as a 1. I'll save it. Now I come back here, I'll run. Now what will happen? It will fail because the total sum is 1.5, which shouldn't be the case. Schedule it. And also, I think you guys know supply planning, how it works. It's not.
Venkat, I think you selected the optimizer.
Oh, is that so? I'm sorry. Thanks, guys. Yeah, and also, yeah, it failed. Optimizer anyway fails. Yeah, I think it's not just the customer thing that it is changing. You guys know it because it's the entire supply plan that gets changed. Because I changed the quota at the customer and the location level, so now that would also impact my production and all other places. It's not just that I maintained 0.5. Now here it became 500. It's not just that. It fails. You can open the business log from here, or you can open that application logs in the front end fair interface. So I open this business log. I can keep a filter and can view on a particular thing. So here it says that you see invalid sourcing ratio. Total ratio of 1.5 is outside of allowed deviation, and the system sometimes is generous enough to actually give you more details that in this period the ratios are okay. There are no ratios here. Okay, just at least giving that 1.5 is a step. So you need to go and change it, and that's why all are like errors everywhere till the end of the weeks. So it is saying that it is wrong. Okay. Yeah, so that's it, guys, for today. Just a quick recap what we have done. So we have
Last question, Venkat.
yes,
Last
please,
question,
please
sorry.
go on. Yeah, go on, please.
Let's say, we only have 2 key figures, right? But what if, we have one more key figure like the stock, right? So heuristic also considers stock as a supply, right? So,
Yes.
but still it's not there. I mean, you haven't loaded. I mean, right? You only loaded capacity as well as the forecast, and then you run the heuristic. So
Yes.
does it automatically, even though you haven't loaded stock key figure, does it automatically look at the stock as well in backend and
Oh
performs the
yeah.
calculation?
Yes,
Okay.
it looks it there and it finds null, and system thinks that okay, there's nothing there. So in the stocks, predominantly there are like few things. One is stock on hand. physical inventory that is lying there, that is available already. So if the stock on hand is 1000 at DC1, then it won't even push the demand onto the production and do a production activity there, because stock is anyway lying. So I'll just use it. It's also another thing called as inventory target. That means the inventory that I have to maintain at the end of the horizon. Could be like a safety stocks or something. So usually the inventory targets come from inventory optimization, but yeah, you can also maintain a value. So system also meets this inventory target heuristic. So now if you say at the dependent demand on production location is 1000, because the overall demand is 1000 at customer, it has propagated properly, and now it is 1000. Now you maintain inventory target of another 500 on this product S12 inside this location called S11 plant 101, then the dependent demand actually becomes 1500. Now system has to do a supply of 1500 at this plant. It does 1500, it ships 1000, 500 it will keep for itself because there is an inventory target of 500. So yeah, what I'm saying is that yes, there are so many other inputs, stock level, capacity level, etc. If you don't maintain it, system is fine. But there are some mandatory things which actually will make the system to run. That is the master data, and from the key figures, it is the consensus demand, and then the capacity supply. If you maintain this, then system would give a basic, very basic result. So this is just a very basic thing, right, that we're doing. So we'll just go step by step. So yeah, all the master data we have seen, and tomorrow we'll take like all this stuff like ratios we have seen, and we'll see other things, and we'll see the impact of it on our entire supply chain. Okay.
Yep. Thanks.
Thanks, guys. Think about it. Come up with more doubts tomorrow. We'll anyway spend another 4 or 5 days on just this supply planning algorithms itself. So heuristics and propagation, supply propagation, and then optimizer, and also there is forecast consumption is there, the standard one. So we'll also see that. Okay.
Yeah, and
Thank you.
will you also
Yes.
please cover this the integration part, right? What I mean to
The
say by that
S4 and
is
IBP integration.
not S4, I mean to say, but like your central component ERP system, right?
Oh yeah, and that is not the on the scope of this thing, because that's been taken care by CPIDS. It's a cloud integration tool. I
Mm-hmm.
didn't even have access to that system. So usually in projects there would be integration team where they will be working with us, and they'll create the integration documents and create the integration projects there. So yeah,
Okay,
this is
no
for
problem.
sure. Sure. Okay. Anyway, you can guys can Google it. There are a lot of videos that are available already on HCI. So, but yeah, I'm telling you, trust me that even though you cry for it, you fight for it, they won't give you the access. From last 3 projects, I am asking for my learning purpose that please give me CPIDS access. I mean HCI access, where I can actually run some projects, and like there it's just an ETL tool. Extract, transform, load. You have to specify what is a source and target. Source is some Mara mark table in S4 or ERP, and some master data in here IBP. So, but they won't give the access, and yeah, our job is just to sit with the team and say that okay, now this is my field. The data has to come in here, and then they will do the project creation, everything. They'll run it, and we have to do the testing, and we'll see that it's working or not. And sometimes we have to go an extra mile and also write down the mappings for the S4 side also. Sit with some S4 guy, get into the right tables, find the right fields, and maintain that mapping sheet. And yeah, that's where our job ends on this integration thing. Okay, guys, then we'll
Okay.
catch up tomorrow.
Yeah.
Bye.
Thank you.